Right, so the first question here says, two personal computers are advertised with different hardware specifications. A quad-core single processor with a quad-core processor with 2 gigahertz and a single-core processor. Now that's there because there would usually be part A, B, C, D, and so on to this question. But in this case, why is it important for these computers to have sufficient amount of RAM? What you've got to make sure you are doing is when it says why, it's not just saying, oh, you're not just saying the more RAM, the faster it's going to go. They need you to explain. The word why and explain are kind of interchangeable in this exam. So for me to know that you know your stuff, I'm expecting you to tell me how it works, all right? So in the mark scheme, all right, it says that a large amount of RAM enables more instructions to be loaded. That is the technical part, all right? So you should have somewhere acknowledged, all right, by having, what am I leaning on? Elastic band, all right? By having more RAM, you can load more instructions. All right. Now, where do you get the instructions from? The instructions come from the secondary storage, because think about it, your operating system is stored on your secondary storage device before it's moved into the RAM, before it's processed. Okay, so that is part one of the mark there. It can load more instructions, right, from secondary storage into the RAM so that it can be processed. That is the second mark there. That is exactly word for word pretty much how it is in the mark scheme. So if you've got more RAM, there you can store more instructions. That's why your computer runs faster. All right, you'll notice if you ever do Control-Alt-Delete and look at the processes, that quite often the browser can take up a lot of your RAM if you're looking at the processes that are running. Okay, so just make sure you've acknowledged that. Now, this question here, all right, what, yes?
Is it RAM that stores frequently used data?
Yeah, the frequently used instructions. Sorry, that's the cache you're thinking of there. The cache store the frequently used instructions, but what the RAM does is the RAM stores the applications that are currently running. So hence, where the application's installed, think about it. When you install Word or a new piece of software, it's installed onto the hard drive, isn't it? But in order to run it, it retrieves it from the hard drive and puts it into the RAM. So it's just a quick recap on that, in case you've forgotten how that works. Now then it says, what is a computer system? Pretty straightforward. A combination of hardware and software. Now some of you may have put a computer system that can do input, process, output, okay? But think about it logistically. If you're going to say input, process, output, you can talk about how your input is your hardware and the processing around it is your software. Think about it, all right? Now we've got a question here. Two typical secondary storage devices with the same cost are advertised as follow. So we've got a solid state drive, all right, with the capacity to store 128 gigabyte. Then we've got a magnetic hard drive with the capacity to store 1 terabyte. Now, before I get into answering this question here, which one's bigger?
The device B.
Yeah, so this one's bigger, all right? This one's smaller, all right? But which one's likely to be bigger in terms of physical size?
B. A.
B again. Bigger, I'm just going to put physical, all right? And again, smaller and portable. Which one is more likely to be more robust?
A.
Good. So that one's more robust. So let's think about this now in answering the questions that are going to follow. State one reason why device B could be considered a better choice than device A. Alright? So what it's looking for there, obviously there's not really a lot of context here. Alright? But if it had a scenario like you are working out at the gym, which one are you going to use to store the data? You're going to use A, aren't you? Because A is more portable, so you could probably get a smaller solid state drive that you can attach to something that you can wear. All right. Whereas a magnetic drive, you're looking at something like that that's this big. All right. So you can't really put that. It's not like you could wear that on your arm to store the data from your workouts. Okay. So there are lots of reasons that you could have had. All right. I'm going to say. Larger storage.
So it has a bigger capacity.
That's what larger storage is. So larger storage capacity you could have had, or you could have said it can hold more data. That's what I would have given for that mark there. Alright? Pretty much the same thing, they're just interchangeable. There's no real other advantage to that. Alright? Two reasons why A could be better. Alright? So this is where it's checking that you have your understanding of the different types of drives that you can get. So first of all, A is, if you put faster, I would not give you a mark for that. So I'm going to say, if you put faster as an examiner, I would not give you a mark for that. But if you'd say faster read write speed, you've extended it and shown what you're talking about. Faster could mean anything. Alright, so say what is faster is what I'm trying to say. Alright, so don't get tripped up on that. Yes?
It's easier to read and write.
No, that's very vague. Okay? What's easier about it? Explain.
I don't know.
Well, there you go. Alright, so that's why it's a vague response. If you don't know what is easier about it, you're not getting to the point. It's that whole so what factor that I talked about with you before. Yes?
Would you say faster read time if you read right?
That counts, yeah. Alright. You can say smaller physical size / portable. They're interchangeable really. Alright. More robust. You could have had less heat. Low power consumption. Lower power. You could say it's lighter, which again, although that would come under portable. It's also quieter. Now, I just want to give you a bit of warning here. There have been times where I've gone through mark schemes where they've not had less heat or less power in the mark scheme. All right. So if it's worth like 5 marks or something, then maybe put it down. But realistically, what you're going for when you're talking about solid state devices is the faster read or write speed, how robust it is, and how portable it is. That's where I would, portable and smaller in a physical size. That's where I would be going. Yes.
Can you say less wear and tear? Since like no moving
Say that again.
less, like you can't get worn out because it doesn't have moving parts.
That's what robust means. Yeah. It's durable. It's more robust. Okay. So if you put the word robust, you could have said durable, which I would have accepted, or you would have said it's less likely to wear out over time. One thing to be aware of though is that solid state drives have a limited read-write speed, so it's not. I would avoid that. Robust means like if you're knocking it or banging it, all right. But actually, in terms of lifespan, I would say that A has a smaller lifespan because solid state drives have a limited read-write time. Okay. Yes.
Isn't robust a bit like ambiguous?
it's been in robust has been in all of the exam specs that I've marked, so it's okay to use that one. All right. Right. An SD card is a type of solid state storage. Two advantages of solid state storage compared to, again, this is just what we've just gone through. It's the same question, just answered in a different way. Okay, so I'm just going to show you the mark scheme for that one there. Lighter, smaller, less power, more robust, generates less heat, quieter. It's the same question as what I just asked you. I just gave you a range of them, okay? Now, question 5 asks you, what is meant by volatile memory? First of all, before I even say this, where is volatile memory? Where? In the RAM, okay? That's another word for main memory, in case some of you have forgotten, all right? What the word volatile means is that when the power is gone, the memory is erased, okay? So when, all right, when the power is gone, the memory is erased. You could say lost. Something. You've just got to acknowledge something that says that that is temporary memory. Okay. As long as you acknowledge that the storage there is temporary and it's gone when the power is gone, you're fine. All right. And it says what is normally stored in non-volatile part of the computer. What is normally stored in the non-volatile, right? So some people, if you've not read that properly, you would have gone to the wrong answer, which would have been applications, because that's stored in the RAM. So in the volatile part, in the RAM, that's where your applications currently running, I might add, are stored. Non-volatile is your BIOS chip, all right? Your bootstrap. When you start up the computer, you know when you see all of the white text when you start up your computer, that is your BIOS chip, and that's the non-volatile, because that can't be changed. It is permanent. That's vague. You can kind of change it. You can flash it, okay? But in terms of the spec, you've got to acknowledge that it's permanent memory. It's not meant to be changed. So what is stored there? The computer's BIOS / startup instructions. Some of you have probably played with that in the past and put a password on your computer. You know when you press F12, that's the BIOS, all of that. Or delete when you start up your computer. Or you've changed the boot order from what drive you want to start up with. Like if you've installed Linux on one hard drive and then Windows on another, so that you can change the order. Now, please, I hope you've got this one. Fetch, decode. Everybody should have got one mark. Fetch, decode, execute. Bear in mind, listen, sometimes in the exam they refer to it as the fetch execute cycle. They do that to catch you out. It still includes decode, alright? So they ask you to explain how the fetch, decode, execute cycle works. Sorry, if they ask you to explain how the fetch, execute cycle works, don't miss out the decode bit. Alright? So, over to 7. Most computers have main memory, RAM and ROM. For each of these two statements, which is correct? ROM is volatile, true or false? ROM, sorry. ROM? False. It is false. In most desktop computers, there is more ROM than RAM. True or false? False. Says more ROM. ROM is just the BIOS chip. You literally only need like a text file stored on it to start up the computer. Whereas RAM, you've got all your applications that are running. They need to work, okay? So your RAM, there's computers with over 16 gigabytes of RAM in them. All right. There are some computers with 32 gigs of RAM. All right. So it. Right. Question 8. All right. I need to get onto the essay question. State 2 characteristics other than size of the cache memory that can improve the performance of the CPU. All right. You could have had the number of cores. All right. Trick question here. You may get asked from time to time in the exam if the increase in the number of cores improves the speed of the processor.
No.
Not always, you're right. Why not though?
Because it just it depends on the clock speed.
Yeah, because you might have a piece of software that is only optimized to run on one core, but if you've got two machines, one that's a single core and one that's a quad core, but the single core has a faster clock speed, that one would run faster because that program is only optimized to run on one core anyway. So just bear that in mind. It's a trick question you sometimes get. So the number of cores you could have had. Anything else? The clock speed you could have had, yes. Now, what you might not have remembered is there's different types of architecture as well. You've got the Harvard architecture. Right. So the processor, all right, there's what we've got is the standard is called the von Neumann, all right. The von Neumann architecture is where you have a processor, all right, and it goes, so this is the CPU, and it goes to the RAM, but in the RAM, you've got your instruction and your data, all right? So that's the standard approach, but what happens is when it gets the information, it has to do all the separating of the data and the instruction in order for it to run, and it can slow down. But there are some CPUs, right, where there is almost like a memory for the instruction and the data, they're separated. So it will go there, then there, instead of having to do the whole separating thing. Alright, so you could change, giving you more here, the architecture. Also, the cache. You could improve the size of the cache.
Other than the size of the cache.
No, it says the size of the cache. Let me finish. Type. Because you know how you've got different levels, like level 1, 2, 3? Yeah, you can change the type of cache as well. So, obviously you couldn't have that, but you could have actually talked about the type of cache. The other thing you can have is the bus width. Right? To get the data to pass backwards and forwards, you have little buses on the computer. Even all, I haven't got one of these. No, I'll show you another time. I've got, right. How is data read from optical CDs? All right. You'd be surprised how many people get this and an actual hard drive mixed up. Now, I'm going to draw you a diagram. I'm going to do it two ways and explain how it works. All right. So on the surface of a CD, optical disc, all right, you can't see it because it's so fine, but the surface of the disc, there are pits and lands. Lands. So, I'll go through that in a minute. Pits and lands. So, when a laser, so the laser goes along the surface of the disc, and whenever there is a change, so like a pit happens, all right, that becomes a 1. So look, just so you can see, so at the moment I started on 0, 0, 0, 0. Then when there is a pit, a change, there's a 1. But when it's staying the same, okay, when there's no change, it just but then it changes again, so it becomes a 1. Then it changes again, so it becomes a 1. Change, 1, change, 1. But the laser is reading that. So the laser is going across the surface, and where there's a change in the depth of that, it knows that that is a 1 or a 0. So, in terms of the mark scheme, all right, what it's looking for is, I'm going to show you this next to it actually. So there's the diagram, and there you go, you can see a CD is spun to ensure all data can be read. Alright, so like I said, the CD spins high speed. CD spins slowly when the laser is reading the outer tracks. Laser is shot on the surface of the disc, that's a mark. Laser is reflected, that's a mark. The bumps and pits are raised on the disc. The bump and pits form a spiral, so you start from the in outwards, alright? And the sensor detects the change. The bumps and pits represent the two possible values of 1s and 0s, okay? Now you can obviously watch this back, but it would be interesting, how many of you forgot how a CD works? Okay, so that was good. It's highlighted something that you've forgotten that you need to be aware of, alright? The next question, I'm not going to give you, a full answer. I'm going to show you how you should answer it, yes.
Land's the flat bit.
Yeah. Pit,
Oh, yeah.
land, alright? Now, the last question was your essay style question. I've obviously not got a sample answer, but I'm going to talk to you about some of the pitfalls of doing those essay style questions, okay? In recent years, alright, we have seen a large growth in cloud storage. So obviously, you've got to write about cloud storage and show that you understand it. So there's your technical marks there. Discuss the advantages and disadvantages, so you've got to make sure you've structured your answer for that. And you should include reasons in recent years and consider any legal, ethical, and environmental of using. That means 3 paragraphs, legal, ethical, and environment. Alright, so you've got to be in your mind now going, right, what are the legal things? What are the ethical issues? What are the environmental issues? Well, let me help you there without the mark scheme for a second. First of all, the ethical issue that you've got is once you've got cloud storage, all right, your files are on there, companies can charge you for the data. So imagine you've got it free, they can suddenly charge it, and you're now in a position where you're like, oh, I've got to pay it because I need the storage. Alright? So you've got the ethical issue of companies charging. You've also, alright, got issues, ethical issues around who owns the data. You've also got ethical issues of cost. Not everybody can afford it, so it's unethical to, that's like me as a teacher expecting you to all have a smartphone. I can't do that because that's ethically wrong, because I'm expecting all parents to be able, that's like me saying everybody has to have an iPhone 16 in my lesson. Could you imagine if I did that? Alright, but then there are some parents that might not be able to afford that. So that's ethically wrong. So that's where you're going at when it comes to ethical issues. Legal issues, you got the Computer Misuse Act. Now, if you just went, oh, does the data comply with the Computer Misuse Act? That's not enough. You need to tell me that you understand it. So, with data being stored in the cloud, we are in danger of people hacking into the cloud and accessing people's personal data. that means that somebody has broken the Computer Misuse Act. On top of that, the company is at fault because they have not protected your data, which then breaches the Data Protection Act. Now, this is where I say as an examiner, so what? And that's where we're falling down when I've spoken to Miss about the ethics questions as well. So what? I've broken the Data Protection Act. What's going to happen to me? Fine. The company can get fined, okay? Or, so what? I've been hacked. Oh, my personal information's now on the internet for other people to access. Extend your answers with that whole impact. If you don't mention impact in your answers, you're dropping marks there. We've still not even mentioned the advantages and disadvantages yet, which is asked. I'm just going through these issues. Environmental issues, right? There are servers. They need electricity. Where are these being stored? In farms. There's data farms. These data farms need to be built on land, so it has an impact. These data farms need electricity. Unless they're using solar-powered energy, they are taking away, they're using like fossil fuels. Do you see what I'm getting at? So there's some key issues there you could have commented on. Then, you can build in the advantages and disadvantages here. Because I can say a disadvantage of using cloud storage is that people could accidentally hack. Not accidentally, but people could hack or access my data. I could say an advantage of using cloud storage is that I can collaborate more easily with people. I can access my data anywhere in the world, providing I have an internet connection. That's also a disadvantage. You go somewhere that doesn't have an internet connection, I am therefore losing access to my files. Now in terms of the marks, alright, to get 7 to 9 marks, there should be a line of reasoning. That means it makes sense. You don't just stop and say, oh, I could get hacked. That's not a line of reasoning. You've not given me that whole so what factor, right? Substantial, again, you need to get the context of the question. One thing I didn't mention there was about the growth. Look, the question said, in the recent years there's been large growth. All right, there's your context. But when you go back to that question, it says here, have you explained the large growth? Well, the large growth has meant that there are more data farms. These buildings get built on land. Maybe there are trees being cut down. Go there with that, all right? But then it says, look, your technology and social reasons. There's considerations of the advantages and disadvantages, but then at least 2 for legal, ethical, and environment. Okay, at least. The reason why I say 3, all right, is because if you underdevelop one of them, then you go straight into the bottom one, right? But if you've got 3 that are kind of okay, you can still get into the top mark band. Does that make sense? So if you stick to 3 paragraphs when there's a 9 marker, you're more likely to get that, all right? I'm going to stop that recording there because the time is up. Look at that for timing, and I will upload that so you can have a look at that, all right?